dear students, once again welcome back for chemistry class. Today I would like to explain you nomenclature of hydrocarbons from chapter 12, that is from organic chemistry. For this you can refer to page number 195 to 199 in your textbook. Nomenclature of hydrocarbons. The term nomenclature means the system of naming organic compounds. Hydrocarbons are the compounds of carbon and hydrogen only. There are two systems of nomenclature which are generally used. They are trivial or common system, UPEC system. Trivial or common system. In the early stages of the development of organic chemistry, organic compounds were named after the sources from which they were first isolated. For example, here, urea got its name because it was first obtained from the urine of mammals. You know mammals? Mammals are the animals which directly give birth babies. Now, for example, methyl alcohol, which was called woody spirit, this methyl alcohol was first obtained by the destructive distillation of wood. Similarly, acetic acid got its name from acetum, which is a Latin word, means vinegar, since it is present in the vinegar. Now next here, UPEC system. Here, UPEC name of organic compound consists of three parts. They are root word, suffix and prefix. Root word, it depends upon the number of carbon atom. If there is one carbon atom, we have to use prefix met. If there are two carbon atoms, we have to use prefix et. If there are three carbon atoms, prop. If there are four carbon atoms, bot. 5 carbon atom, pent. 6 carbon atom, hex. 7 carbon atom, hept. 8 carbon atom, oct. 9 carbon atom, non. And 10 carbon atom, det. Now here, next here, suffix. Suffix means is the letter or the word added at the end of the name. Prefix. Prefix means the word that is added just before the root word to indicate the presence of substituent in the organic compound. Here, now, next, general rules for naming organic compounds. When we are naming organic compounds, the first step, we have to choose the longest continuous carbon chain. The longest chain need not be straight, but it should contain maximum number of carbon atoms and should be continuous. This longest chain is known as parent chain. All other carbon atoms which are not included in the parent chain are called substituent. As you can see the structure of this organic compound. Suppose if you take this chain, 1, 2, 3, 4, this contains only 4 carbon atoms. If you choose this one, 1, 2, 3, 4, 5, it contains 5 carbon atoms. If you choose this one, 1, 2, 3, 4, 5, 6, this is the longest carbon chain. It contains maximum number of carbon atoms. And this CH3 are not involved in this chain. So these are called substituent. CH3 is known as methyl. This methyl is obtained by removing one atom of hydrogen from methane. So methane, its molecular formula is CH4. When you remove one atom of hydrogen from methane, you will get CH3, methyl. Similarly, if you remove one atom of hydrogen from ethane, you will get ethyl. Now next we will numbering the carbon atom in such a way this substituent would get the smallest possible number. If you number the carbon atom from left hand side, 1, 2, 3, 4, 5, 6, the position of this methyl is in third, is joined to the third carbon atom, and this is joined to the fourth carbon atom. If you numbering the carbon atom from right hand side, 1, 2, 3, 4, 5, 6, same, third, fourth. So we're numbering the carbon atom from left hand side. Here, so we'll write the position. This is 3, this is 4. How many methyl? 2 methyl. This is dimethyl. Now this finish. Now we'll take this one, longest chain. 1, 2, 3, 4, 5, 6. Hex. There are 6 carbon atom hex. And the nature of the bond. See, carbon is a tetravalent. Here, for this carbon atom, this is 1. This is 2. This is 3. This is 4. We'll write hydrogen here. For this carbon atom, the 1, 2, 3, 4. We'll write hydrogen here. For this carbon atom, 1, 2, 3 and 4. This hydrogen we'll write here. For this carbon atom, this is 1, 2, 3, 4. We'll write hydrogen here. Similarly here, 1, 2, 3. This for carbon atom, 1, 2, 3. We'll write hydrogen here. 4. For this carbon atom, this is 1, 2, 3, 4. So for this carbon atom, 1, 2, 3, 4. We'll write hydrogen here. For this carbon atom, 1, 2, 3, 4. Single covalent bond. So the suffix is Ane. And the UPAC name of this compound is 3,4-dimethyl-hexane. Now next here, if any functional group is also present, same rule should be applied as in the case of substituent. As you can see here in this structure of organic compound, their OH is functional group. So here in this case, we number this carbon atom in such a way, this functional group would get the smallest possible number. If you number it from the right hand side, first, second, third, fourth, fifth, the position of this OH is in fifth, is joined in the fifth carbon atom. So this will be wrong. So we're numbering the carbon atom from left hand side, first, second, third, fourth. This is fifth. Now we'll write the UPAC name of this compound. So first we'll write the substituent. So 3-methyl. 3-methyl. So here 1, 2, 3, 4, 5 carbon atoms. Single covalent one. PENTAN. Here alcohol, the UPAC name of alcohol, E of alkyl molecule is substituted by OL. So pentane here, PENTAN is the position of OH is in second, so we'll write 2OL. If different types of substituents are present, we'll arrange them in alphabetical order. As you can see here in this structure, there are chlorine and bromine present. We'll arrange them in alphabetical order. Now next we'll number the carbon atom. This bromine would get the smallest possible number. If you number from here, left hand side, first, second, third, fourth carbon atom. If you number the this from right hand side, this bromine will join in the second side, second carbon atom. So we'll number from here. I'll write the UPAC name of this compound. The position of bromine is second carbon atom. So I'll write 2-bromo. Chlorine is in third carbon. 3-chloro. Now this finish, here this finish. Now here 1, 2, 3, 4, 5 carbon atom. Carbon is a tetravalent. Here as you can see here this carbon. Here 1, 2, 3, 4. Here for this carbon atom this is 1, 2, 3, 4. We'll write hydrogen here. For this carbon atom this is 1, 2, 3, 4. We'll write hydrogen. For this carbon atom this is 1, 2, 3 and this hydrogen will here. Then for this carbon atom 1, 2, 3, 4. This for this carbon atom this is 1, 2, 3, 4. We'll write hydrogen here. So all single covalent bond. Now how many carbon atom? 1, 2, 3, 4, 5. Pentane. PEN. Single covalent bond. So ANE. 2-bromo-3-chloropentane. Next, for writing the structural formula from the UPEC name. Suppose we have to write 3-methyl pent-2-N. Pent means 5 carbon atoms. ENE means double covalent bond. It belongs to alkene. So first we will write the skeleton structure of pentane. Pentane. So pentane means 5 carbon atoms. Now next we'll numbering the carbon atom. First, second, third, fourth, fifth. Now here the position of this double covalent is joined to this is in the second carbon atom. Second carbon atom is here. So we'll write here. First, second carbon atom. Now next the position of methyl. Methyl is joined to the third carbon atom. Third carbon atom is here. So we'll write here CH3. Now we'll write the hydrogen atom for all these carbon atoms. Carbon atom is a tetravalent. So here 1, 2, 3, 4. For this carbon atom, this is 1, 2, 3, 4. For this carbon atom, this is 1, 2, 3, 4. For this carbon atom, this is 1, 2, 3, 4. For this carbon atom, this is 1, 2, 3, 4. Or you can write CH2 also. For this carbon atom, this is 1, 2, 3, 4. Instead of this, you can write CH3 also here. CH3. Here H. Here H. Here H. Instead of this, we can write CH3. Here H. Instead of this, we can write CH. Instead of this, we'll write CH2. Instead of this, we can write CH3. So this is the structural formula of 3-methyl-pent-2-ENE. Here the position pentane, pent means 5 carbon atom, 1, 2, 3, 4, 5. ENE means double bond. This double bond is in the second carbon atom. And 3-methyl is third carbon atom, CH3. And this is the structural formula of 3-methyl-pent-2-ENE. Dear children, here we have come to the end of today's online class. Thank you very much.